In this video, we're going to talk about adding and subtracting radicals. Well, let's review on how to simplify an algebraic expression. What do? Well, we're going to combine like terms. So I know 3x minus 4x is negative x, and 5y plus y is a positive 6y. We just combine like terms. Well, I can do something very, very similar with radicals. So let's take a look at this radical expression. 3 times the square root of 2, I can combine with negative 2 times the square root of 2. 3 minus 2 is 1, and I'm going to leave the square root of 2 alone. Negative 7 times the square root of 3 plus 1 times the square root of 3. Well, that's negative 7 plus 1, that's negative 6 times the square root of 3. So what we did here was combining like radicals. Like radicals are radicals that have the same index and radicand. So I've given examples of like radicals and not like radicals below. Notice with the not like radicals, the second example, it is the cube root of 6 and the square root of 6. So I have the same number under the radical, but my indices, one which is 3 and one which is 2, are not the same. That is why they are not like radicals. So, to add or subtract radicals, we want to simplify each radical by pulling out perfect roots, and then we want to add or subtract like radicals. So, let's simplify the radical expressions. So, the very first example, these are not like radicals, but let's see if we can pull out any perfect roots. So, notice here, the square root of 32 simplifies to 4 times the square root of 2 after I pull out all the perfect roots. And the square root of 50 is the same thing as 5 times the square root of 2 when I pull out all its perfect roots. So I'm going to replace the square root of 32 with 4 times the square root of 2 and the square root of 50 with 5 times the square root of 2. These are now like radicals. I can combine them. 4 minus 5, that's negative 1, and I'll leave the square root of 2. But I'm going to leave my answers just negative times the square root of 2. All right, so let's take a look at the next example then. Again, looking at all 4 of these radicals, none of them are like radicals. But again, I need to check to see if I can pull out any perfect roots. So I'm going to take a look at 63, 27, and 28. So notice the square root of 63, after I pull out all its perfect roots, is 3 times the square root of 7. The square root of 27 is 3 times the square root of 3 after I pull out all its perfect roots. And the square root of 28 is the same thing as 2 times the square root of 7 after I pull out all its perfect roots. All right, so let's substitute these in for the problem. So 4 times the square root of 7 remains exactly the same. 5 times the square root of 63, well, that's plus 5. The square root of 63 is 3 times the square root of 7 minus 3. The square root of 27 is 3 times the square root of 3 minus, I'm going to write on the next line here, 2. And the square root of 28 is 2 times the square root of 7. All right, so we need to simplify. So that's 4 times the square root of 7. 5 times 3 is 15 times the square root of 7. 3 times 3 is 9, so that's minus 9 times the square root of 3. Minus 2 times 2 is 4 times the square root of 7. So, what are my like radicals? Well, it's 4 times the square root of 7, 15 times the square root of 7, and negative 4 times the square root of 7. Now, this one is nice because 4 times the square root of 7 minus 4 times the square root of 7 is 0. So what am I left with? 15 times the square root of 7 minus 9 times the square root of 3. These are not like radicals, and I cannot pull out any more perfect roots. We are done here. Okay, one other example I want to take a look at, but now we're dealing with a cube root. So remember, we need 3 of the same factors in order to pull anything out. So let's do these perfect roots on the side. So the cube root of 81x to the fourth is the same thing as 3x times the cube root of 3x after pulling out all the perfect roots. And the cube root of 24x is 2 times the cube root of 3x after pulling out all its perfect roots. Okay, so now let's plug these in. So I've got a 10 to the outside. Okay. I will replace with 3x times the cube root of 3x minus 3x. And then it's going to be times 2 times the cube root of 3x. So 10 times 3x, that is 30x times the cube root of 3x. 3x times 2 here is 6x. And that's times the cube root of 3x. These are now like radicals. They have the same index, which is 3, and the radicand, which is 3x, so I can combine them. 30x minus 6x, that's 24x, times the cube root of 3x.